Hey guys, so this lesson is to tie together a few things from the last few lessons. What I'm going to do first is I'm going to place a little protractor on top of this circle. Now, when you have a protractor like this one, you would measure your angles from either the right or from the left. Just make sure you follow along the correct numbers. So if you're going from the left side, you would go from here, 0, all the way up to say 90, 180. And if you were starting on the right, the 0 is here and you would go that way. So what I'm going to do first is I'm going to create a 30-degree angle similar to the one we had on our circle in one of the previous lessons. And that 30 degrees will go from the initial side until the terminal side, and that would get us out to about here. So I'm going to draw this 30-degree angle, and then I'm going to cut out a triangle with a radius of what I consider to be 1, which will be the radius of this circle. So this triangle right here, so the hypotenuse of the triangle and the radius of the circle will be considered 1 unit. I'll also do another one with a 45-degree angle, and I'll do another one with a 60-degree angle. And as soon as I have those cut out and ready to go, I will show you what I have. But let me just show you one more step of how I start this. So right here, I know that little mark to the origin makes 30 degrees, and I will drop down an altitude. You probably remember that phrase from geometry. Drop down an altitude right from here to the x-axis. So that's the little, well, that one's not perfectly straight, but I'll do a little better. So that's what I'm going to cut out. I'll do one of a 30-degree angle, then I will do a 45, and I will do a 60. All right, and I'll show you those in just a second. Okay, so here you see I cut out my triangles. This one here has a 30-degree angle, 45-degree angle, and a 60-degree angle. In other words, that's pi over 6 radians, pi over 4 radians, and pi over 3 radians. Pi was 180 degrees, like we said, so 1/6 of 180, or 1/6 of pi, is 30. Pi over 4 means 1/4 of pi, so 1/4 of 180, or a quarter of it, is 45 degrees, and pi over 6 is 1/6 of pi, or 30 degrees. Now that I have these triangles here, I want to show you how they matter when we are analyzing those ordered pairs we began to talk about yesterday. So here we had 0 degrees, or 0 radians, and we went all the way around the circle until we hit 360 degrees or 360 radians. We also said there that that was 0 radians, and we said that that was 2 pi radians. Here we had 180, and we also called that pi. Now, I'm only going to draw those angles in for right now. We have to remember that this is 30 degrees. If this is 30 degrees, that means this tick mark is 30 degrees. Standard position begins here and sweeps up counterclockwise. When we wrote out this 30, 60, 90 triangle yesterday, or in the last lesson, we said how this radius or hypotenuse was 1. That meant that this leg right here was 1/2, and that this leg would be radical 3 over 2. If this is at the origin, and this is an ordered pair we're curious about, we would move over radical 3 over 2 for our x value, and then we would move up 1/2 for our y value. So together, we did the first quadrant of ordered pairs. Now, what if I took that same triangle and I reflected it over the y-axis? I did a horizontal reflection. Well, just because I reflect something doesn't mean that this angle changes. If this angle was 30 degrees, it's still 30 degrees. Or pi over 6, right? Pi over 6 radians. So if that was 30 degrees, and we know that this is 180 degrees, then how many degrees does this spot represent right over here? This tick mark, if I drew this line all the way down and I was sweeping this around, how many degrees would that angle represent? You could just look at it as 180 minus 30. And what does 180 minus 30 leave you with? 150 degrees. So our ordered pair, if this were plotted on the XY plane, our ordered pair that we would get on the terminal side of this triangle would be the same as this ordered pair, except instead of moving right radical 3 over 2, we move left. And then we still move up, so 1/2. Now I could take that exact same triangle and I'm going to reflect it now vertically. If I reflect that triangle vertically, this side length still doesn't change. When you flip a shape, flip it, reflect it, rotate it, you did this in geometry. The dimensions don't change unless you dilate this, but we're not doing that. So the ordered pair that we would find over here would be very similar to the ordered pairs we just did. We would go left and down. Again, this is still 30 degrees or pi over 6 radians. What angle does this represent? We look at the x-axis. We could either call it 210 degrees, or if this is pi over 6, pi is really 6 pi over 6, so we could also call this 7 pi over 6. 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. The ordered pair is left radical 3 over 2 and then down 1/2. One last ordered pair to do. We reflect one last time, or we could have, I guess, gone in the negative direction and gone this way first, but here we are. 360 degrees is the whole circle. 30 is where my finger is. All right, my up in here is 30. So what's 30 less than 360? 330 degrees. Or if this is again pi over 6, 2 pi is 12 pi over 6. Take away a pi over 6, it's also 11 pi over 6. So you need to know that place by heart as 11 pi over 6 or 330 degrees. And if you don't yet, you need to draw this unit circle over from a couple lessons ago about 12 more times, okay? So this ordered pair, I still went radical 3 over 2 and 1/2, my direction changed. Positive radical 3 over 2 and negative 1/2. Those are the ordered pairs that went with the pi over 6 or the 30-degree angle. Also, if you look, they make a rectangle. They are all the tick mark that is closest to your x-axis. You can do the exact same thing with your 45-degree angle or pi over 4 radian angle. I have an ordered pair that we got to go along with that as well. We did the 30, 60, 90 triangles. We solved under the condition that the hypotenuse was 1, and we determined that this would be square root 2 over 2, square root 2 over 2. That means your ordered pair, that's the origin. We know that the radius is set to 1 for this circle. Square root 2 over 2, square root 2 over 2. Both are positive numbers. 45-degree angle over there. What about that angle? What angle would this be right here? If it's 45 degrees between the x-axis and the terminal side is where the hypotenuse is. That's 45 degrees, or pi over 4. What's 180? Take away 45, because it's 45 less than 180. So make sure you're paying attention to the fact that I keep referencing this angle here as it relates to the x-axis. Okay, listen to that sentence again. I keep referencing the angle over here. I'm actually even going to go and draw a little theta this time, between the terminal side and the closest x-axis. This angle would have been 135 degrees, 180 minus 45. Or we could have done pi minus pi over 4. Pi is really 4 pi over 4. Take away 1 pi over 4, and you have 3 pi over 4. Just going to go and sketch out these tick marks so I don't mess these up. So 3 pi over 4, 4 pi over 4. This is pi. If we add that same amount, we could say it's 5 pi over 4. Or we could say 180 plus 45, 225 degrees. I'm still going left, radical 2 over 2. That's still that distance. It doesn't change. The triangle's measurements stay the same. And then I go down radical 2 over 2. So this time I have two negative numbers. And then we know that this is 45 up in here. If that's 45 and that's 360, 360 minus 45 to get the angle going around that way. And what do we get? 315 degrees. Our ordered pair would be square root 2 over 2, comma, negative square root of 2 over 2. Now, this should be very easy at this point. This triangle is the same as this triangle, except we're looking at it from the perspective of the 60-degree angle. You should already have those tick marks drawn out on your paper. You should already have everything figured out from there. What's that ordered pair? And what's this angle? If this is 60 here, this is 0, it's 60 degrees, or pi over 3. Ordered pair. We go to the right 1/2, and we go up square root of 3 over 2. Reflect this over the y-axis. We do that. This right here is left 1/2 up square root of 3 over 2. So negative half, positive square root of 3 over 2. Reflect it again. That's theta, it's 60 degrees. That's 180. What's 180 plus 60? This is 240 degrees. What's the ordered pair over here at 240 degrees? Negative 1/2, negative square root 3 over 2. I don't know if I said what angle this was, but we again have 60 degrees right there. I want you to go from 180. You're not going to go from here and add the difference over there. Go from 180 minus 60, 120, or pi minus pi over 3. 1 pi over 3 subtracted from 3 pi over 3, that's 2 pi over 3. Last but not least, there's still 60, 360, so it's 300, or this is 2 pi, also known as 6 pi over 3, minus 1 pi over 3, 5 pi over 3. And what's that ordered pair? To the right, 1/2, and down square root of 3 over 2. You need to know the ordered pairs that go with each tick mark by heart. I also went over in the previous lesson what these numbers are as decimals. So I'm just going to slide this over. 1/2 is pretty easy. That's just 0.5. Square root of 2 over 2 is approximately I think I said it was 707-ish. And then square root of 3 over 2 is approximately 0.866-ish. 1 over 2 is the same as the square root of 1 over 2. So now there's a little bit more organization. Rad 1 over 2, rad 2 over 2, rad 3 over 2. I like to think of this as small, medium, and large. To get to this tick mark, I go over large, up small. I go over medium, up medium. I go over small, up large. Everything's in the positive direction, so both values of my ordered pairs are positive. Here, to get to this tick mark right there, I'm going to go to the left large, up small. I can go left medium, up medium, or I could go left small, up large. Going left is negative, going up is positive. Large, small, medium, medium, small, large. And as long as you remember what the small, medium, and large are, which aren't too bad to remember, you can remember your ordered pairs. It's very important. You cannot mix up your X and Y, obviously, because these would be wrong, and you can't mess up your positives and negatives. So if I asked you, what's the X coordinate that corresponds to 5 pi over 6? You need to know. If I asked you, what's the Y coordinate that corresponds to 5 pi over 3? You need to know. Here you'll do the same thing, except we're moving right and down, so you have positive and negative. Quadrants 1, 2, 3, and 4. Now we're very close to tying this all together. I would say one last thing. Let's actually know the ordered pairs right here. So this ordered pair is 1, 0. This one is 0, 1. This over here is -1, 0. And this one over here is 0, -1. I only labeled the angles here, and you should be able to do in your head, by the time we meet next, you should be able to tell me the X or Y coordinate of any angle between 0 and 360 degrees or 0 and 2 pi radians. Then we'll add another layer to this, the actual layer of right triangle trigonometry. I hope you understand. I hope you at least kind of get it. And if not, watch it again, and I will be assigning a quizzes to go along with this for you to practice knowing what I want you to know by heart. Good luck.